Welcome to the Nokia SR Linux Learning Essentials video series, brought to you by the Nokia Data Center Fabric Certification Program. This video explains SR Linux access control lists on ingress interfaces. So, what is an access control list? An ACL is a kind of filter with a set of ordered rules. When an ACL is applied to an interface, the system will check every incoming or outgoing packet on that interface against the set of rules. Match criteria are based on various protocol frame header fields. When the packet matches a rule, the associated action is executed. This action can be either accept or drop, which means the packet is blocked. Additionally, matching packets can be logged for further analysis. There are some special access control lists that work only on control packets terminating on the router. They are called CPM filters. They are similar to regular ACLs but can also rate limit these matching control packets. SR Linux also supports another type of ACL called the capture filter. It lets you analyze matching packets in a similar way to the Linux TCP dump tool. In this video, we will only cover the regular ACL filter on an incoming interface. Now let's see a use case for an ingress ACL filter. We have a leaf spine data center with 3 hosts attached to leaf 1 and 1 host attached to leaf 2. We want the hosts on leaf 1 and leaf 2 to communicate with each other. But we want to prevent a host from reaching the system IP addresses of the routers or the leaf-to-spine interface IP addresses. For this, we're going to create an ACL filter that matches these IP addresses and drop all other traffic. And we are going to assign that filter as an ingress ACL filter on the host interfaces of the leaf 1. That's the green and red paths on leaf 1. Okay, we will now configure the ACL for this use case in our training lab. Let's first verify the current lab connectivity. We're going to log on host 10 and verify that we can ping host 20, but also that we can ping the router system IP addresses. Now let's ping the system IP address of leaf 1. It works as well, but this is something we want to block with an access control list. Now let's go to leaf 1 to configure the ACL filter. You need to go to the candidate mode. We go to the ACL branch. The ACL filter is called Allow Host to Host, and the type is IPv4 and a description. Now let's add our first entry 10. So we are going to match traffic with destination IP addresses of the hosts. So we enter IP before prefix /16. This will cover both our leaf 1 hosts and leaf 2 host. Next, we specify the action, which is accept. Now we need a second entry that will drop all the remaining traffic. And we create entry 999 with the action drop. We don't need a match statement. Here it is. Then entry 10 to allow host-to-host traffic. All IP packets that have the prefix 192.168 as destination IP address are accepted. And finally, entry 999 that will drop everything else. That's it for the ACL filter itself. Some ACL filters are applied automatically to all the interfaces of an SR Linux router. That's the case for the system, CPM, and capture filters. But an ingress or egress ACL must first be assigned to the interface on which the packets will be filtered. This is what we are going to configure next. Here, host 10 is connected to leaf 1 on the interface Ethernet 1/10.0. So we enter the command ACL interface Ethernet 1/10.0. Then we have to specify the direction of the packets. We want to filter ingress packets, so we use input. And finally, you specify the name of the filter that we just created and the type. IPv4. And that's it. We can now commit this configuration. Now that we have applied the ACL filter to the host 10 interface, let's check if it works. We go back to host 10 and ping again host 20. It still works. That's what we configured with entry 10 in the ACL. Now let's try to ping the system IP address of leaf 1 again. The ping fails. Let's connect back on leaf 1. To verify the ACL, there are dedicated commands that can be used. Let's start with the command show ACL summary. It gives an overview of all configured ACL filters. In our case, we don't have any CPM filters or capture filters. We have configured one IPv4 filter. It's active on one subinterface in the input direction. Another command, show ACL IPv4 filter, gives a bit more details. Entry 10 has a match for a destination and the action is accept. Entry 999 matches every packet and the action is drop. The TKM is a super fast memory chip that implements the ACL filters on each line card. The number of TKM entries is limited. Also notice that there is a match packet count. It shows 0 for each entry. It's in fact because statistics are disabled by default. We will show how to enable them in the next slide. We have seen the main attributes of ACL filters. There are a few more options. There is also a log action. When this is configured, like for entry 999 here on the right, some details about matching packets are then made available. To see them, a new log must be configured under System Logging. We also mentioned the match count statistics on the previous slide. Statistics are disabled by default and can be enabled by setting the statistics per entry parameter to true. In our trading lab use case, we have assigned the ACL to one interface, but each interface ACL can in fact be assigned to multiple interfaces. In this case, the match count statistics will be the aggregated count for all the interfaces using the same ACL filter. To change this behavior, we can enable sub-interface specific statistics. You will then see a separate match count for each entry and for each interface. That's it for SR Linux access control lists on ingress interfaces. Thanks for watching, and be sure to explore the rest of this video series to learn more. And when you're ready to practice what you've learned, my DCF Learning Labs provides comprehensive exercises with step-by-step instructions and solutions, all in one simple browser-based application.